An apple falls from a tree. A planet orbits its sun. You labor your bicycle up a hill and accelerate smoothly down the other side. All those things are down to gravity, working exactly as Isaac Newton said it did almost 3.5 centuries ago, a force that tells massive objects how to move. A force that holds us all down and governs the very universe itself. So, what exactly is gravity? In the simplest of terms, gravity is the force of attraction between two masses. The larger the masses, the greater the gravitational pull. This is why we are all held down to the Earth's surface and why the planets are held in orbit around the Sun. But how does this force work? Well, according to the latest data, gravity is actually the curvature of spacetime caused by the presence of mass. This means that any object with mass will warp the fabric of spacetime, causing other objects to be attracted to it. In fact, it was the great Albert Einstein who first introduced the concept of spacetime and how it is affected by mass. His theory of general relativity revolutionized our understanding of gravity and gave us a more accurate way of measuring it. But let's get into the nitty-gritty of things, shall we? The strength of gravity is measured by the gravitational constant, which remains constant throughout the universe and is approximately 6.674 into 10 to the power minus 11 Newton-meter square per kilogram square. This might seem like a small number, but it's actually incredibly powerful when you consider the immense masses of celestial bodies in our universe. For example, the force of gravity between the Earth and the Moon is what causes the tides to rise and fall. The gravitational pull of the Moon creates a bulge in the Earth's oceans, which causes the tides to move in and out. Gravity also plays a crucial role in the formation and stability of our solar system. The Sun's gravitational pull keeps all the planets in their respective orbits and prevents them from flying off into space. In fact, the largest object in our solar system, Jupiter, has such a strong gravitational pull that it actually protects the Earth from potentially hazardous asteroids and comets by deflecting them away from our planet. But what about black holes? These mysterious objects have such an incredibly strong gravitational pull that not even light can escape them. In fact, black holes are so powerful that they can warp spacetime to the point where time itself slows down. Speaking of time, did you know that gravity also affects the passage of time? According to Einstein's theory of general relativity, time is relative to the strength of gravity. This means that time actually moves slower in areas with stronger gravitational fields. For example, time moves slower on the surface of the Earth than it does in space, where the gravitational pull is much weaker. This is known as gravitational time dilation and has been confirmed through experiments using atomic clocks. So, as you can see, gravity is an incredibly complex and fascinating force that governs the very fabric of our universe. It affects everything from the tides on Earth to the stability of our solar system, and even the passage of time itself. While we may not fully understand all the intricacies of gravity just yet, we can continue to explore and discover its mysteries through scientific research and observation. Who knows what new revelations we may uncover in the future? Until then, keep exploring and expanding your knowledge. So, this was all on gravity. I really hope you liked this video. Thank you for watching.